So from the previous video, we're able to plot these data sets, the pH against the time and the assumption against time. So now from the integrated data set, we got that the analysis we did, since the graph is a dumbbell graph, we need to integrate it to get a sigmoidal graph. But assuming the graph was a sigmoidal graph, we have to differentiate it to get a dumbbell graph. So from our plot, we got a dumbbell graph. We're going to integrate it, which we got data set. For that data set now, we have to input the data set and plot again. So the values we integrated, we got x1, which is equals to, you put it again, introducing a parenthesis also, called data set, which is 2.2, separated by semicolon. So we are inputting the values. Then, so close by with a parenthesis, then end with a semicolon. Next. Oh, so you can see there's an error while inputting this value. I made a mistake not putting the semicolon at the first one, so you have to input the dataset again. When using Matlab, you have to be very sensitive of errors because of Matlab is a very sensitive toolbox that when you make a mistake, either in the semicolon or the parentheses or even the data name, it will change everything. So we put the data again, or we can just copy it directly and edit it. So we copy it, then we paste it, then from here we can edit it. So now we introduce the word integral. Let's call that int xi, or let's call it int xi, int xi. So put the data which is starting from 0, 1 point, 35026, 3.47837, 6.24723, 9.76096, 13.96 960 961, 18.833. We have 24.362, 30.532, 37.3279, 328, and 44.736. Close again, semicolon, enter. Then you just keep converting toolbox, press enter. So now we're going to create another data set. Your x-axis now is the xi, while the y-axis is the int xi. So you can see now we create data set and close. Now we have to go to the plotting now. We remove the pH against time for the plotting, and the plot there remaining there will be what? The int x. So we go to fitting now. Now, since the graph we're working with, now is an integral graph, so we have to change our equation. Still on custom equation, we have to go and what? Press a new equation. So general equation, we have to introduce the what? That's our integral equation that we derived. So our integral equations derived was that kb minus ci over kph times exponential open bracket minus k ph dot x plus cm naught over km open bracket km
You see? Hey, replay. Yeah, replay.
so it will be km bracket km
I know go take it, no be need.
minus kph
How easy they talk.
multiply
You should kill me, no go
by
pay.
exponential minus km times x. So we have to be careful with the
I said, why would they shoot so needy? The second one is for what? For waiting. For you took me too needy for my bed. I know. Replay. How you saying it beyond the game? How?
so error somewhere. Locate where the error is coming from.
And tomorrow I will go, they no go full.
So
They no go full.
there's an error, so we have to rewrite the equation again. Let's see where the error is coming from. So this guy is correct. So the error issue is now where? The issue is now is from where? Okay. Yes, plus what?
You just did inside since. When you come back,
Cm naught over what?
see when you do that place,
Km bracket Km
when you do that side,
minus
the one you go to that place.
kph
But it's spread up to 2
times
hours.
exponential minus Km so see I've gotten the equation now.
Wait, you continue
Then
tomorrow again.
we can now change the lower limits to zeros, or the lower limits to zeros of the equation. Change all the lower limits to 0.
Time process now. Time process now.
Now it is 0. Change all the lower limits to 0.
Process is wrong. It's up.
Press OK. Now we click on the equation, then we apply. Let's check our fit options. Okay, let's apply it. Let's see what it looks like. So
You see? You don't use medicine. You see waiting. Oh. Well, you come out.
so you can see, let's use our axis control to control the plot.
Once you move back my head, you find Papa. You don't know where Papa is.
Baba the
How about choke now?
down here now. And this is
Who be the person? Who? Where the place is? Eh? Wait, how you didn't know the person? How you didn't know the person? How?
So
How you think you know that person? I will tell you. Ask the person now so that I know what I'm doing. Ask him now. Now. I want to know. How much is it? Should not pass 1,000.
so you can see this is the plot for the
So ask.
integral part. Now you can see the value of the r square,
I say you
goodness
go
of
ask.
it, and the coefficients we got from the data. The coefficients we got kPa, km, kb, cm naught. Then we have r square.
Am I touching this one? Am I touching this?
We just say r square. We can see from the plot that the r square is better than the adjusted r square. Why? There's introduction of variables. If you look at the constant, there are more constants in the equation of the together values than the equation of the normal plot. So there are more constants: kb, kph, cm naught, km, kph. So those constants tends to drag the r square. Those constants in this equation shift those adjusted r square away from the r square. It punishes the model.
Come here and say.
So that is why the adjusted r square will always be lower. I didn't mean there are fewer constants in the plot, or in the equation, the
Today.
r square and the r square will be the same value. So from here we can say our plot is ready. Then we can now use print to figure. Then from here we can check the ultimate value. The ultimate value by what? Dragging it. You can check the ultimate value. The point where
Waka.
where the f value stops changing, or where there's a change, where there's a sharp change in the value of the y
Ella.
part. So as you can see,
Can.
it's still changing. It's changing.
I feel now. I feel now.
So let's bring this young man out of the box. Then from there, so you see there's no change.
Bomb belly. As and you be like this. And you be like this.
See there's all. See now, so this is where the change starts. So this is the ultimate value. Where there's a change, this is a sigmoidal plot. Then from there we can print to figure and adjust the axis by what? Inserting the x and y label. X label, this is the what? The integrated xi. Then tap on it to arrange. Insert the y label. Sorry, the x label
You won't call him.
is the x values. You click on it, you arrange.
Ella.
Then you insert the what? The y label, which is the integrated xi. Click on it, it's arranged by itself.
I say,
Then
are you calling him?
you can now what? Copy the figure and save it. Then this session you are done. The key things you should know in this plot is when to what? Integrate. When to integrate, like I said earlier, if the plot is a dumbbell plot, like if the plot is a dumbbell plot, we have to integrate to get a sigmoidal. But if the plot is a sigmoidal plot, you have to differentiate to get a sigmoidal.
No.
Then you use your custom equation to insert your equation. You apply. If the fitting is not good, come here and raise the number of iterations. That is 6,000. Let's try this. We are getting a 9.0.977 r square. So let's see if we raise the number of iterations. What will affect? Whether it affect the r square? Let's check it. Let's try an error. Let's try something. Let's see how it will affect the r square value. So let's apply it and see. So you see that the number of iterations didn't affect anything at all. Let's see if if you notice we not even use a lifter in the plot. Let's see whether using a lifter in the equation will change the plot. So let me use a lifter. Let me introduce a lifter here. Let me introduce a lifter here. A lifter called, let's call it F. Then a lifter. So lifter, let's raise the lifter to the highest value of the integrated value, which is 10. So let's let it to 10 and see how it affects the plot. So let's see. We see that the lifter reduced the r square of the plot. It reduced the r square of this plot. So this plot don't need a lifter. Doesn't need a lifter. So if you know when to use a lifter or not, you can see. Let's go back to normal and see. You see, it has a better r square value, meaning that the lifter is not needed. The lifter is not needed at all times. So this video I'll be able to explain this plot. Thank you very much everyone. Wish you all the best.